In this video lecture, we're going to look at the differences between writing procedures in Visual Logic versus writing procedures in Python. We'll look at some of the ways that we can pass parameters into procedures in Python, how we can have a procedure return a statement, and how we would format our code that is going to use procedures. And additionally, we'll start to talk about a concept called variable scope. So let's get started. So over here on the left-hand side of the screen, I have Visual Logic. And one of the things we have to keep in mind is how procedures were originally built. And remember, procedures are ways for us to break our problem up into smaller programs. It's way easier to solve small parts of a problem and then chain those small parts together to solve bigger problems. And that's what procedures allow us to do. So in this specific case, if I go up to the procedures menu, I only have my main procedure, which is, remember, the main procedure is what the program basically is running without any additional procedures. It's, the program proper as we think about it. Every program needs an entry point, it needs something to run, and in most cases this will be called main. So let's go here and add our own procedure that we can call from main, so we can kind of encapsulate some process. In this specific procedure, I'm going to call it hello, and I'm going to say okay. I'm not going to use any parameters or arguments. I'm just going to put them here. And what happens in Visual Logic is we get dumped into this separate interface. So there's this very real, clear separation between when we're editing the main procedure versus when we're editing another procedure. And this procedure is going to be really basic. What I'm going to do is I'm going to just output the word hello. And then what we'll do is go back and we'll end up writing this in Python as well. So once I've got this taken care of, and I've written the procedure the way I'd like it to be, I'm going to return to my main procedure, and I need to call my procedure. So once I've defined the procedure, I need to go ahead and call my procedure. So in this specific case, I go to my main program, or wherever I want to call it, and I come down to my available procedures that I've written, and I select the hello procedure. Note that, this is a pretty inefficient procedure in this case, because I'm really only, printing the words hello is really just a single line of code. But in this case, it's a little bit more compact from the fact that, if I wanted to change this to a different language or something, it would be easier down the road to make modifications, especially if I have multiple calls to this procedure in my code. So I'm going to go ahead and run this, and you'll see that it says OK. If I want to, I can add multiple calls to this procedure, right? And it should print hello twice. Hello, and hello. And we're done. So let's delete one of these, and now let's move over to Python and look at how we create a procedure in Python. I'm also going to use the name function. It's probably worth noting that these terms are interchangeable, and in the reading for Python you'll see the term function. So functions, procedures, they're interchangeable terms. So what I'm going to do is go ahead and kind of talk about how we lay out our file. So first thing we're going to do is at the top of our file is we're going to define our functions. We always want to define our functions at the top of our text file, and then later on we're going to write the code that uses the functions. So we're always going to define the functions first, because if you remember, our code is top-down, so it'll start executing at the top, go to the bottom. So it's always better, in my opinion, when we're writing single-file Python programs to actually go ahead and define our functions at the top, and then the code that utilizes those functions will be at the bottom. For this specific class, we basically put all of our code in a single file. But there are ways in Python where you can separate your code into multiple files and packages and all types of other ways to make larger programs more efficient. That's not really something we focus on in this class, but it is something that you may want to consider as you learn to write more Python. So in this case, I'm going to ask you to write all your functions at the top, define all your functions, and then we'll write the code that leverages those functions at the bottom. So let's look at how this works in Python. We're going to use the def keyword, which is probably a short for define. We want to define a procedure or a function, followed by the name hello. And hello is going to be the name of our function, just as it was in Visual Logic. Now, specifically in Python, we want a procedure that accepts no parameters. So previously, like in my hello program in Visual Logic, I had no arguments that were passed in there. Oops. And if we look at this procedure, you can tell there's nothing after the name hello over here. So we note that there are no parameters or no arguments. So every procedure needs to have a set of parentheses after it. In this specific case, because we want no arguments to be accepted by this procedure, there's nothing inside of these. And much like we did with conditional statements, we want to end this line with a colon. So this is one of those cases where we have a colon delimited line. So to rehash, Def is required. This is where we define our function. Hello is the name of my function, and the naming pretty much follows the conventions we talked about previously in Visual Logic, followed by an opening and closing parentheses that may or may not have some stuff in between it. Right now, I have no arguments that I wish to pass into this procedure. Therefore, I have nothing between those parentheses. And finally, we terminate the line with a colon. And again, much how the Python runtime environment knows where a line ends in this case is because of that colon. So it's got to be there. Now, much like as well when we used conditional statements, any code that we want associated with our procedure will be indented underneath of that definition line. So exactly the same kind of rules that we utilize with conditionals when it comes to setting up an environment that uses functions. So I'm going to go ahead and I'm going to put my print statement in here. And again, I'm using Python 3, so I'll use Python 3 print statement. And now we're done. So here's where my code has been defined. Now down here, I'm going to go ahead and I'm going to call my procedure. So line 8, when this program runs, these definitions basically set these functions up in memory so they're ready for us to use. And then down here on line 8, we're going to use them. So if I run this, once I make this a little bit more easy to see, what you'll note is I get hello, the exact same output. If I wanted to print hello a couple of times, much like I did in Visual Logic, I can paste this a couple of times. And what we'll end up with, is the exact same output, just multiple times. So note that everywhere this procedure is called, it gets outputted the exact same way. And again, remember, one of the conveniences of using procedures is that we can make a change in one spot and it's instantly reflected everywhere that gets called. So I can change to hola and we can instantly see that that's reflected in all the calls to the procedure. So what I'm going to do is I'm going to go back to Visual Logic, and I'm going to now modify the hello function, and I'm going to delete it here. And I don't really know how in Visual Logic to delete a function. So what I'm going to do is leave the function that's called hello there, and what I'll do is add a new one called hello2. So I'm going to add a new procedure over here called hello2. And in this specific case, I want it to accept an argument. So remember, arguments are things that we can pass into a procedure that can help us do work. And I'm going to name this variable name, because what I'd like to do here is have a hello procedure that generates a custom name. And so remember, this is our formal argument, and then our actual argument will be what we end up passing into it. And now what I'm going to do is I'm going to set up my output statement just like I did before. Notice now the name here is hello2, and there's my opening and closing parentheses. And there's a variable name now between those two. Arguments are variables. And essentially what's happening here is any value that gets passed into this procedure is going to have that value stored into the name variable. And then within this procedure, I have access to that name variable. So let's go ahead and print our hello statement again. I'll put a space in here, and I'll use Visual Logic style concatenation. And so what you'll note is I'm going to take the string hello and concatenate it to the value stored in the variable name. Well, what's the value going to be? It just depends. When somebody calls this method, we will see. So I'll go back to my main method, or my main procedure, and what I'm going to do is call my hello2 procedure. All right, and if I double click on it, because this procedure accepts parameters, I can go in there and put in the string JSON, or the name of the variable that I want to pass into this method. So my formal parameter is called name, and my actual parameter is going to be the string JSON. And if I print this, I end up with some output that says, hello JSON. Now, if I want to call another method, call hello2 again, and if I want to, notice I don't have to pass a procedure in, or sorry, I don't have to pass a value into the procedure. So notice hello JSON. And I get an error, okay, in this specific case, because even though I can add this procedure to my main procedure, and I can have it be in the timeline. Notice that it doesn't complain at that point, but when I run it, I get a runtime error because, well, even though it looks like I don't have to add a value, really what happens here is because I'm missing that argument, it gives me an error. So a procedure that asks for an argument needs to be passed an argument. Again, there are ways around that, but in our terms and the way we're learning about procedures in this class, we want to make sure that if one is necessary, we can easily pass one in. So we don't have to worry about any of those additional rules that you may know about, like method overloading or anything along those lines. So in our case, if a procedure asks for a value, we want to pass one in. So notice I can call the same procedure with different arguments. First I'll get hello Jason, then I get hello Joe. So not only does this allow us the ability to easily change some code in one spot and have it reflected in multiple places, it also lets us build reusable chunks of code. And what makes this reusable? Well, I can say hello to any user whose name I pass in as an argument to this procedure. So let's go over here and write this in Python. I'm going to put a line in here just so there's some difference between, a little bit of space between the old hello and the new one. I'm going to call this hello2. Now, what's going to be different is I'm going to want to pass in an argument. So I'm going to go ahead and I'm going to put name inside of those parentheses. And now, if I want to, I can go ahead and add that variable or utilize or access that variable anywhere inside of my program. And just like I had to do when I called hello2 in Visual Logic, I need to call this and pass in a parameter. And if I clear and run, notice it says hello Jason. Notice there's two spaces there because I'm using the comma syntax for the print statement, so I don't really need that extra space in there. So we can see how this operates when we pass in two separate sets of strings. So I pass one string to the first invocation of the procedure and to another one, and we can note how reusable the code actually is, and we can look and see how this directly corresponds to things in Visual Logic. One thing we did not do in Visual Logic was write methods that returned a value. So if I go ahead and create a new procedure, and what I'm going to do is I'm going to call it num times 2, and I'm going to add one argument to this procedure, and I'll call it num, and what you'll notice we'll have to pass one value into this procedure when we call it. Notice that there's really no option here for giving a value back. Like we talk about this idea that num is how we pass a value into this procedure, but how do we give a value back from the procedure? Just like an ATM machine gives you cash back, after you give it the input of an ATM card and a PIN number, and may possibly and a withdrawal amount. How would we write a method or a procedure or a function, right? Kind of all somewhat interchangeable if we take the most vague, loose definition of those terms. To give us a value back. Well, in Visual Logic, we really can't easily do this without discussing some topics that we're not going to get to in this course. But what I do want to do is look at how this process works in Python, the process of returning a value, and how it differs from printing something. So let's write this in Visual Logic real quick. And so what I'm going to do is I'm going to say num. And I'm going to put a string in here, which will be times 2 equals, all right, and then we'll put and we'll basically do the num times 2 right here. So I'm going to pass a value into this procedure. I named it num times toe. I'm not going to go back. That's a really good example of a bad spelling error, but that's pretty funny. So what I'm going to do is set this up so that when I pass a number in, whatever number gets passed in, it gets multiplied by 2, and then I'll build a custom output string here. And if I go back to my main procedure, I can call this procedure. What I'm going to do is pass in as my value, as my actual value, the number 10, And remember that value can come from user input. It can come from anywhere. I'm just hard coding it to keep the code very simple. And if I run this, I'm going to get output that says, hey, 10 times 2 equals 20. 10 is the value passed into the procedure. 2 is the value that I've hard coded to multiply anything passed in by. And then 20 is my output. But notice this is like inside of a print statement, right? There's really, what would be really great is if I could actually have a variable on the left-hand side and a way to basically have this procedure call on the right-hand side. And as far as I know in Visual Logic, I don't think you can do this. And I think there's some design reasons why they set it up this way. But this is something that we can do in Python. So let's look at how return statements work. So we're going to go over here and we're going to define our num times 2 method. And I'm going to spell it correctly here. And let's go back and look at how this looks in our procedure editor so we can make sure that this is correct. And so over here in the procedure editor, right, again, you can see that I'm defining a new procedure in Python. It is named num times 2. It accepts a single parameter named num. There's my line terminator. And if I were to write this exactly like I did in Visual Logic, it would look like this. And so let's actually set this up so that it works that way. And again, I always forget these put spaces in, so we don't need those. I'll get rid of these calls. And what we'll do is we'll put num times 2, and I'll put 10 in here. So this procedure is going to be very similar or identical in this case to the previous procedure. I'll hit run. And again, we get the exact same output. 10 times 2 is 20. To be honest, I think this is way more readable in Python. I think all of this is way more readable in Python. So this is a little weird, though, because like, what if we wanted to write a graphical user interface? We're not going to talk about how to do that this semester. Or what if we wanted this answer to appear on a web page? Like this print statement, all it knows how to do is print things out to the console. But what if like we have a user that just refuses to use the console, right? They're like, hey, this is 2017. I don't use the command line. I use GUIs. I use the web. I've got an app for this, whatever. So having this actually print something to the screen is a bad idea. What would be really cool is if we could take the value that is produced by this procedure and store it into a variable. So I'm going to set up a variable called myAnswer on the left-hand side. For this to work, what we actually need to do is go ahead and get rid of this print statement. And what I want to do is actually return a number. I want to return the value that's produced by taking a number and multiplying it by 2. And so we use a keyword called return. And what do I want to return? I want to return the number the user passed in, and I want to go ahead and I want to multiply it by 2. And now, why is this helpful? Well, you'll note now if I run this program, I get no output. Why? Because this procedure does not print anything. There's no print statement in it. And nowhere in my code down here where I'm writing my program do I print anything. But what I could do is go ahead after I perform my calculation and save the answer into this variable. I could say something along the lines of print the answer is my answer. And what you'll find is when I do this, put these right on the same line, right under each other, I get the answer is 20. Why? Because I went ahead, called my procedure, right, my function, passed in the number 10. Again, this could be a variable. This value could come from anywhere. The calculation inside of the procedure is performed. The number is then returned. What it means to return a value is it means that a function, any value returned by a function, can be stored in a variable or used anywhere a variable can be as well. So in other words, I can use the function where the variable is. Let's copy these 2 lines to see how this looks. And note that I don't need to actually use this variable. Anywhere I can directly use a variable, when a function returns a value, I can just put the function call. I can basically put it in line. Right? I can inline the function call. And let's add a different value here so we can see that this is a different call. And we can run it. Pretty cool. So you have the option when a procedure returns a value to either store that value into a variable and then use the variable, or if you just want to kind of get a value and print it, you can put that procedure call directly in line. A lot of neat things that we can do with functions in Python. So one of the things that I also want to point out is a concept of variable scope real quickly. Is I want to notice that this variable number inside of this method is actually only exists inside of this procedure. Sorry, I keep saying method. I usually teach Java. So this function here in Python, when we create this argument or any other variables that you create inside of this function will only exist inside of the function.